The nice thing is the answer's there. The hard thing, we had some multiple choice on the test yesterday, and I had people, none of these answers work. You're right.
Some of the answers were a little weird.
Yeah, because they broke it up. They broke it up to like x equals 5 and x equals -5 versus x equals plus or minus 5. So
yeah, no, I just the one of them I did the wrong way to solve it. So I was like so confused because I got no real solution.
Ah, I gotcha. All right, so my friends, we are going to be talking about exponents and kind of some of their characteristics. All right, so let's start filling a few of these things in. These x values here, that's the base. These values here are the exponents. Okay? Friends, exponents with like bases, when they're being multiplied together, you count up the thing. So I have a base of 3. I have a base of 3. I'm also multiplying. So what did I do here with my two exponents? I add them. So 5 plus 7 is?
There's something else. Since this is an actual number, if you square down the answer for the square root first, would it be the same?
Yeah, and I would say that 3 raised to the 12th power is huge. It's only 531,441. But I'm not looking for that. I'm looking for you to leave it as a base with an exponent. Oh, that's a great question. Why is it not 9? Why didn't I multiply? So that I really like that question. Okay, so let's try and answer that. So 3 times 3 is 3 squared, agreed? Which is also 9, right? So 3 to the second and 3 to the second is 3 to the fourth. And my friends, I need you to put your phones away. I've seen some of your grades, and some of your grades suck. And I can assure you, nothing on Snapchat, Facebook, or anything like that is going to improve your grade. I will start taking phones away, and you can start picking them up at the end of the day from the dean's office. Okay? You're at school. She should know that. All right, so you agree that 3 to the second, 3 to the second with what we just did is 3 to the fourth, which is the same thing as 3 times 3 times 3 times 3, which is 2781. So why don't I multiply that? Well, I kind of sort of did. Okay, so this is the same thing. 3 to the 12th is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if I were to multiply this whole thing out all the way across, it was some huge number. So if you have the like bases and you're taking care of the exponents by adding them, you do not need to multiply the bases together. And I just kind of proved it here in a simplistic way. Does that make sense? Okay, try it again. This is 3 to the first, 3 to the first. Agree? Which is 3 to the second. Agree? And I can multiply 3 to the second to get 9. So I got rid of the exponents by multiplying them. So let's say if I had 3 to the second, 3 to the second, I'm going to add those, which is 3 to the fourth, which is the same thing as 3 times 3 times 3 times 3. So I could multiply those out to get 81 because that's not a huge, enormous number. Hang on. So if, why do I not multiply the bases together? Like bases, when I'm multiplying them, and those bases have an exponents, we will add the exponents together and not worry about multiplying the bases. Because 3 to the fifth is, I have this many 3s. I know that's a 5, but I have 1, 2, 3. Those are 3s. And then I have this many other 3s. So it's just basically how many 3's I have altogether.
Um,
So here we're going to get into a little pun. Exponents, my friends, are like bunnies. You still with me out with the bunnies? Yet we've all seen these bunnies that are jumping out in our yards these days, right? So you look out front and you go, how many bunnies do I have? I got 1, 2, 3, 4, 5, 6, 7. I have 7 or bunnies to the 7th power. So exponents are like bunnies. When they're all next to each other in the yard, count them up. That's a joke that's going to go for a little bit.
Wait, what if it's division?
Like
if it's 3.
We'll get there. We'll get there. All right. So, let me go back a screen. Oh, I still had a problem here. So, friends, what is that going to be based on our rule up here? X to the 7th power. So if it's x to the 7th, I didn't go x times x to get, I counted up, I added those. Okay? So, if I have the same bases, and those bases are being multiplied, and those bases are raised to an exponent, we count the exponent up. As I said, exponents are like bunnies. Bunnies are our bases. How many bunnies do we have in the yard? We count them up. This is a power to a power. I'm raising an exponent. I have a base. I have an exponent. And I have another exponent. So it's a power to a power. Power to power means I'm going to multiply my exponents together. When I multiply my exponents together, I get x raised to the mn, where m and n are being multiplied. So power to a power. 3 to the 4th to the 5th. What should I do to the power to a power? Multiply. So that's 3 to the 20th power. Same thing. That's 20. Same thing with this. What do I do here? Multiply. Okay. X to the 14th. Now, you remember I told you that exponents are like bunnies. Here's your cross-curricular biology and math lesson of the day. You ready? So if bunnies are all out in your yard, you just count them up, just like exponents. When you have stuff that's down, you count up the exponents. So bunnies are like exponents. When they're next to each other, you count them up. When they're on top of each other, you
Add another one.
Geez, you get the joke? If exponents are like bunnies, when they're just in your yard, you count them up. When they're on top of each other, they multiply. Hey, see? Oh. All right. So, I have a good friend of mine. His name's Tony. And he asked me not to call him that anymore. So I said, why not? Okay. The jokes are getting worse. Jokes are getting worse. All right. So, my friends, exponents on top of each other, they? So I get 2 to the 6th power. Now, friends, realize I'm not going 2 times 2 times 2 times 2 times 2. I'm just leaving it as 2 to the 6th. So what do you think I should do in this situation? I'm going to add, so I'm going to get 7 raised to the... Okay, now this was something that came from the quadratic formula. Oh, I like it. So what is squared? Yeah. Right. Good, good, good. Excellent. So the 6 is squared. So my answer, if I said, hey, what does this truly come out to? It's negative 36. Because the 6 is the only thing being squared. If I wanted to make sure it was a positive number, I'm going to go negative 6 squared, and that's going to give me a positive 36. So the big difference between these is I have parentheses, and I don't have parentheses here. Yeah.
If I cube a negative 36.
Ooh. So if you cube it, and we put it in parentheses, a negative times a negative is a positive. A positive times a negative is a negative.
So it would be okay.
Yeah, absolutely. Good deal. So basically it becomes, if I have something in parentheses and it's raised to an even power, 2, 4, 6, 8, 10, it's going to be a positive answer. If I remove those parentheses and I have a negative raised to a 2, 4, 6, 8, it's still a negative answer. Ooh, okay. Go ahead.
So the answer to this is negative 36.
But if I grouped negative 6 in parentheses or square brackets, I don't know what the difference between square brackets and parentheses are other than they're not curved versus curved. So that's what we got. All right. Do we feel comfortable so far with what we're doing? Let's get back to the pen. Okay.
Does that mean you square root each side?
Ooh, wow. I X root each side, but I'm not going to do that. That's a little goofy.
You divide each side by 4.
No, I can't do that yet because the exponent is that. Yeah. No, not yet because it's 4 raised to the x, not 4 times x. So this is our exponent right here. Okay? Yeah. Not yet. You got something in your ear. Okay. I'm going to make one move here. Everyone agrees with this, yes? You're happy with that. I'm just bringing it down. 16 is the same thing as 4 squared. Agreed? So now I have the same bases. So you know that x has to equal 2. Done.
What x equals 2? Because it's a square root.
It's not a square root. It's an exponent.
I mean, yeah, it's an exponent.
So 4 squared is? If I take...
4 squared is 16.
Yeah,
if it wasn't a 4 and it was an 8.
Oh, we'd have to try and change it up if we can. Yeah, there gets to a point where you have to realize I can change 16 to make it 4 to the second. 16 is also 2 to the fourth. 2 to the fourth, meaning 2 times 2 is 4, times 2 is 8, times 2 is 16. So this is kind of, we try and keep this in mind. And the thing when we're dealing with exponents is I can only deal with small base numbers if I'm solving it because exponents get really big really fast. Okay, so now this one over here looks a lot different. I have 5 raised to the n power, 5 raised to the n, where this is my exponent. Okay. No, I can't because the exponent's taken away because in my order of operations, exponents comes before multiplication. So I have to look at the exponent. So let's put some things generically. Do you agree that this is 5 to the first? Or 1 over 5 to the first? Is that the same thing? If I have a number, is it raised to the first power if it just sits there as a number? Okay. So this wants to move up. It wants to move up. So my friends, if something moves from being on top to being on bottom, or moves from bottom to being on top, you only missed 2/3 of the lesson. It's a good thing I record. And you missed a test yesterday that you have to do. Got it? Because everything's counting as zeros till it's made up.
Yeah.
And we're almost done with the school year, right?
Mhm.
I will not grade anything in June.
Yeah, we'll get it them.
Okay, thank you. So if I am going to move something from being on the bottom of a fraction to moving up top, the exponent changes its sign. If I wanted to move something that was up on top, if I want of a fraction and it wants to move down to the bottom of a fraction, the exponent changes its sign. So what is the sign on the exponent right here if it's just 5 to the first? And do you feel it's positive 1?
Yeah.
So ready? So with what I just said, if it wants to move from bottom to top or top to bottom, the exponent is going to change its sign. Wait a minute. Where did the 1 go? Technically, it's down here, right? But any number over 1 is just itself, so I'm not going to worry about that. So what does n have to equal here? Done. That wasn't impossible, I don't think. I think the tougher problem is this one. So you have to remember your order of operations. Exponents have to take place before add, subtract, multiply, or divide, right? That's your PEMDAS that they kind of threw at you, and you're like, you give me this PEMDAS, parentheses, I haven't seen, exponents, what is this you speak of? Multiply, divide, oh, I know that. Add, subtract, oh, I know that. So this is where the PEMDAS comes in. I have a number to an exponent. So then if I have a number to an exponent, I have to think, can I break something else down to a different base with an exponent? Okay, so let's kind of recap. Let me just go, is that I have that and that and that. Got a few of those, okay. Oops. All right, so I have like bases, my friends, and we are multiplying it. So what did we say we do when we have like bases? We add the exponent, so it becomes 4 plus 6, which is x to the 10th, and it's done. Like bases, add the exponents, right? 4 plus 6 is 10. Okay, Dan's worried that we now have a negative. Oh, hang on, it might be. Oh, Dan, you're right. How? Yeah, negative 2 plus 7 is 5. 5 plus 3 is. So this just becomes this exponent of this, which is x to the 8th. Yeah. Power to power, what do we do with the exponents? So those get multiplied. When I have an exponent of an exponent. So basically, if you have a hard time realizing to multiply it, this is the same thing as x to the 4th, 2, 3, 4, 5, 6 times 6. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24. So that's x to the 24th. So power to power, you multiply the exponent. So like x to the 24th. Holy moly, guacamole. That gets to be a big thing quickly. Huh. So I know you've heard the little silly story. If someone's going to hire you and pay you a penny a day, doubling it every day for 30 days, or they're going to give you $10,000, what would you take? To a penny a day, because it gets up to like $17 million, because it doubles. It's an exponential growth. Exponential growth grows very fast. So if you ever come across someone who's going to hire you to do that, call me up. I'll go with you. I'll get hired by them too. All right. Uh-oh. I have like bases. I'm multiplying them. What should I do with the exponents? Add them. So I have to go 1/2 plus 1/3. Okay, so c raised to that. Let's do this off to the side. 1/2 plus 1/3. Which way should we add fractions? You want my butterfly method, or you want to go back to 4th grade math method? Really? You want to get a common denominator? Because I like doing it this way. 3 times 1 is 3. 1 times 2 is 2. 2 times 3 is 6. So I get c to the 5/6. But if you want to go back to 4th grade math, we get 1/2 plus 1/3. Common denominator. What number does 2 and 3 both go into? Oh, 17. Okay. Now that becomes 3/3, so you get 3/6. And that goes 2/2. That gives me 2/6. And 3/6 plus 2/6 is 5/6. Or you can use my method. Crisscross, bottom, multiply. Multiply the x's, multiply the bottom. Done. It's a beautiful thing. Why didn't your teacher teach you that? I don't know. Yo. Okay. So, hey, friends, I have a base of x, I have a base of 4, or a base of x. Agree? I happen to have a number that comes along with both of these. So I'm going to get -12 first. -12, and then the x. Like bases, what am I doing with the exponents? Add them. 11 plus 15 is 26. The x is the only thing raised. The x is the only thing raised to an exponent. Yeah, but yeah. So it's like you independently work this and this first. You worry about the letter with the exponent second, but they're still connected. Huh. Where am I at in the notes? How are we doing with this? So I'm giving you an awful lot of information. I got there. Oh, hey, calm down, stirrup. Not that. Where else? Got, looks like 2 more problems left, huh? Yeah. Do what? Uh-huh. They are added together. My way of adding fractions, a over b plus c over d. This can represent any numbers you want other than having 0 in the denominator, right? So a times d, c times b, b times d. So you add those on top. Oh, so if I had 4/5 plus 7/8, 32 plus 35 over 40. Yeah, totally add those together to get 67/40. And then you check to see if it'll reduce. This one won't. But that's what I would do. And it'll work every time. And I'm sorry your elementary school teacher didn't teach you this method. Because I can assure you, if elementary school teachers taught this method, none of you would come here going, uh-oh, we got fractions. I promise you that. Why don't they? Because the geniuses of Common Core had 0 interest in educating kids. They were selling textbooks to schools and making a ton of money off of it. Oh, but Common Core is great. Bill Gates says it is. No, he didn't. Want to know why Bill Gates thinks it's great? Because coming with those textbooks are computer programs that schools can buy, computer programs that Bill Gates' company wrote, and Bill Gates' company designed the computers for it. Oh, but Common Core is great. No, it isn't. Great for Bill Gates and all the people who profited off of it. Everybody else?
I think Bill Gates stepped.
Huh?
Didn't Bill Gates step down from the head of Microsoft?
I don't know. But when Common Core came out 20 years ago and they were like, oh, this is what they do in China. No, it isn't. Oh, I can show you the data. Okay, show me the data. Well, just because I can't show you doesn't mean it doesn't exist. But you said you had the data. Well, I do. Okay, show me then. Well, just because I don't have it doesn't mean I don't have it. That's your argument? Okay, friends. 2 questions left. I'm going to multiply those together. What do I get if I multiply those together? Anybody stuck so far? So I'm going to put an X there. I'm going to add those, and I'm going to add that. So 3 plus negative 3 is?
0.
Feel good about that? 0 added to 7 is? Done. Think it's okay. All right, hang on.
Did you multiply the numbers this time?
You what?
Like the other time you went and multiplied.
Because the number was raised to an exponent. These numbers don't have an exponent that they're raised to. So 5 times 2 is 10. Now, if I have x and y just sitting there, those are both to the first power. So multiply those. What do I get? X to the third. Y to the... Done. I think that's all I have. Hey, do you guys want a lot of homework tonight?
No.
Oh, cool. How about we do EEF, and this will be on, I'll put this on Schoology too. EEF, number 1, and let's just do the odd problems. That's all I got. Friends, this is the